Okay, thanks for coming to my talk today. My name is Rick O'Connor. I'm with the OpenHW Group, and this is an open source organization developing hardware. Obviously, a lot of history with open source software, but open source hardware is a relatively unproven, at least from a commercial adoption standpoint, here to date has been relatively unproven. This ecosystem is changing that. Before we go further, though, if you haven't seen any of the other talks that are here at EclipseCon, there was one yesterday that Frederick and Davide gave downstairs. There's a couple more this afternoon, and we have a Birds of a Feather session this evening. Hopefully that'll be an open forum for discussion, people learning a little bit more about the possibilities of open source hardware and what that adoption can look like, specifically here in the EU. And in particular, the BOF is going to cover a bunch of topics, or can cover a bunch of topics. These are the sort of 5 discussion areas that we've thrown out there as topics for potential discussion. Obviously, we can take any other discussion around the topic, but some folks might not be that familiar with the RISC-V ISA. We'll kind of go over that and the history of where it came from and what it's about. Talk about different processors that are in development in the open source community, and what does permissive licensing mean for hardware relative to what it means in the software domain. And I talk about that in this morning's talk a little bit as well. Certainly one of the lessons learned. Anyway, come to the BOF if you want to have more of an interactive discussion around that. So for this talk, I'm going to give a little bit of an overview of the OpenHW Group. I'm not going to bore you with the history of open source software. I think you guys, this community would pretty much know that pretty well. But there's a couple of lessons that we can take from the software community and our software friends and brothers and sisters and adopt that into the hardware community. So I'll touch on a few of those points and then jump into sort of 3 lessons that we've learned over the last 2 years. The open hardware ecosystem is a little over 2 years old in terms of its operational performance, and we'll go through those 3 lessons. So the OpenHW Group is a nonprofit, a global nonprofit registered in Canada and in Brussels through our partnership with the Eclipse Foundation. And really it's an environment where hardware and software developers focus on curating industry-grade, high-quality silicon IP that can be used in high-volume production SoCs. So it's literally taking the notion of open source software and open source artifacts and drilling it all the way down to the gates in the silicon. And it's an international organization. We have member companies from all over the world, both on the industrial and academic side, and a very, very strong community. So there's close to 100 members and partners at the table now. When not a lot of people are aware of it, and then when they see this slide, go, oh, wow, that's a lot of companies. And some big guys, Intel, NXP, Silicon Labs at the silicon level, major cloud guys like AWS and Alibaba. So there's lots of interesting actors at the table participating in this ecosystem. And the intent is that we have an ecosystem that covers everything that you would expect to see around processor enablement. So software development, OS porting, tool change, IDEs, reference designs, the IP itself, obviously the verification of that IP, SoC designs. Global Foundries is a member, and we build reference kits with Global. So a pretty active community. This is a snapshot of the industrial members. Here's a roster of the academic members, and then some of our partners who are at the table helping us to curate these open source artifacts and bring them to the ecosystem. And the way that we're structured is as a board of directors, has their hands, if you will, tightly on the steering wheel, driving the direction. And underneath the board, there are 2 main working groups, a technical working group and a marketing working group. And the technical working group is effectively the R&D of the organization, with a handful of task groups that drive the various technical projects that are active in the ecosystem. So the cores task group looks after the processor cores, the verification task group verifies those cores, and then the hardware and software task groups are similar to internal customers, if you will, for those cores, where the hardware task group builds FPGA emulation platforms, SoC reference designs, and the software task group does all of the software work around tools, IDE, OS porting, and so on. And together with the Eclipse Foundation, we're partnered with Eclipse. We use, as our engineering release methodology, we follow the Eclipse development process. And we have more than 20 projects underway within the ecosystem right now, all driven by the members of the open hardware ecosystem, ranging from the RTL itself for the cores, like I said, through verification, software tools, and so on. So it's a very, very active and vibrant community. The technical working group is chaired by Jérôme Gavreman from Thales. And they, as I said earlier, really drive the technical working group is the R&D of the ecosystem, if you will, and drives all of the projects within the ecosystem. And as I mentioned a moment ago, we follow the Eclipse development process for our engineering release methodology. And everything is publicly available on GitHub for download and use by anyone. You don't need to be a member. Just where you go, it's complete open source. So you might ask, well, why should I be a member then? Well, the members are the ones who decide what the projects are, decide the features and functionality of those projects, and the priorities of those projects. So in terms of shaping the direction of where the roadmap goes from an IP standpoint, that's driven by the members. If you just want to use, which is obviously never appreciated in the open source community, giving back is always a good thing. But like any open source project, there are plenty of users who are just users, and that's more than fine. Okay, I'm going to really go through the history part, but touch on a couple of key points in terms of relative to the 20-year history or so in open source software. Where are we from a hardware ecosystem perspective? So this is known, right? Open source, it's not free, but it's freedom of use. And if you look at some of the key milestones dating back to the mid-90s, in the sort of first 2 decades of open source software, we're kind of like 2001, where you got folks saying things like, open source hardware, that'll never work. You can't go to production. I use this analogy all the time. If you're a hardware engineer, you're going to walk into your boss's office, throw your badge down on the desk, and say, "Hey, boss, I bet my job on this cool piece of IP that I just downloaded from a university GitHub repo, and we can put it in our next multi-million-dollar SoC tape out, and it'll be great. Let's go." There's clearly a lot of interest and activity in the ecosystem, as I said earlier, with 100 members and partners. But even inside each of those companies, while there's the enthusiasts that are hanging around in the open source community, there are many others inside those same companies that say, "Hey, this is silly." Open source hardware, there's just so many layers to the onion that need to be peeled back. It's very difficult to get to. So we're kind of at the level of 2001, and even rush on new licenses. What is a permissive license as far as open source hardware? How does that apply? So we got a ways to go before we get to 2015, and ARM joins an organization like this and says, "We love open source hardware." We're pleased to have some pretty big players like Intel and NXP at the table, pushing on this kind of innovation. But there's still a ways to go. So it's a fun journey, and if you want to help shape the direction of where this goes, I welcome you to join. Okay, what does it mean to have permissive use in open source hardware? So if you look at the adoption of open source licenses, copyleft style licenses are certainly dying away, with Apache being the most prominent open source license from a permissive standpoint. And again, if you look on this slide, Apache and MIT are the top 2 license usage, and if you look at the growth of permissive adoption, and all of this makes sense, right? The ecosystem needs to be structured such that adopters are incented to give back because it's good for them, not because they need a hammer over their head that says they have to give back. We kind of take it on the chin a little bit, because we have, it's like I said, there's many layers to the open source hardware onion. It's impossible to build an SoC right now that is relevant from a performance standpoint on completely open source IP. It is impossible. So that means there needs to be a pragmatic approach to how you marry commercial and proprietary IP with open source IP. And if you're going to do that, that means you got to get the big guys to the table, like the NXPs and Intels of the world. And if you're going to do that, that means the only way they're going to play is if it's a permissive license and they grant back because it's good for them, not because they have a hammer. So how do you actually address that from a hardware company standpoint? These large systems and semiconductor companies have very, very deep patent portfolios. That's the reason that the only thing that'll work is permissive. There's a huge anxiety, if you will, around the exposure of that patent portfolio, that IP portfolio that those companies have amassed over decades into the industry and being encumbered in some way because they're participating in an open source project. So copyleft, like I said, style licenses are just a no-go. Okay, so Apache is fairly well adopted in most of these companies. Pretty much every one of the large systems and semiconductor companies, the software team in those companies are well familiar with Apache. The IP review council and lawyers departments in those companies go, yep, Apache, we've signed off on that before. So clearly we should just have a hardware license that is just Apache. But is Apache enough? And there's been a fair amount of work done by Morsecroft LLP. So Andy Katz is a well-known and respected lawyer in the open source community to build a license on top of Apache called SolderPad. And it's literally just a handful of new definitions that sit on top of the Apache license. And that's the license that we use in the open hardware ecosystem. We use Apache for sure where it applies. And these new definitions sit on top of Apache. And as a result, the review inside the Intels and NXPs of the world is very, very short. Because they go, yep, Apache's good. Oh, and these extra terms? Yeah, no problem, let's go. As opposed to a brand new license. So this has been very effective. I'm not going to go through the details of what SolderPad looks like. We can talk about that in the BOF later. But if we go back to the lessons and stop just for a second on the permissive use, we spent a fair amount of time looking at the success of permissive licenses in the open source software community, how to migrate that success into the hardware community, and that's where the SolderPad licensing came from. The next is, again, go back to the analogy, I'm going to throw my badge down on the table, bet my job with my boss and say, yeah, this is cool IP block, just got it from a really, really cool university and we're going to use it. Yeah, but is it any good? What does it look like? And so on. So probably the biggest effort in the open source community in the open hardware group is our verification task group, where we have a couple of industry veterans from Paris and Thales that chair the task group to develop what we think is a best-in-class verification test bench for RISC-V processors. And we have, again, going back to the embracing commercial IP and tools. If you're a large volume semiconductor house, you use Mentor tools, Siemens now. You use Siemens, Synopsys, or Cadence. You might use some smaller company tools alongside those, but fundamentally those big three EDA companies are must-haves. The other aspects are the number one language for capturing hardware RTL is SystemVerilog. And so we are focused pretty much exclusively on that. And then from a verification standpoint, there's a verification standard called UVM, Universal Verification Methodology, or methods, and we're focused on that. So we have this test bench that's completely open source. And this is not a simulator or an emulator. This is not for software development. This is to find the bugs in the hardware before you tape out. Right, there's a verification test bench for RISC-V processors, And everything on here, except for the reference model and the SystemVerilog simulators that sit underneath here, either from Synopsys, Cadence, or Mentor, is completely open source. So the stimulus is open source. It's a random instruction generation tool that Google developed and is open source. Is leveraged heavily in this test bench. And if you're familiar at all with how processors are verified, this is a state-of-the-art step and compare methodology where the DUT is compared to a reference model, and at the retire of every single instruction, that comparison of those two machines happens. You don't wait for the end of a simulation, a long simulation, to find out that something failed in the first few cycles, kind of thing. So it's quite an interesting test bench, and what we're finding actually is we have companies participating in the ecosystem not because they want the cores that are being developed in the cores task group, but because they want to use this test bench for their own cores. So we know we've done a good job when that starts happening. And we also publish our coverage data. So this is a fully coverage-driven verification methodology, functional coverage, code coverage, assertion coverage, FSM coverage, with appropriate waivers. Every chip gets taped out with some waivers that get signed off, but the coverage data is completely published on our GitHub repos, and we've got a very clear criteria for RTL freeze, which is the final milestone, if you will, in releasing an IP block, saying that it's ready for high volume production. And then there's a lot more work that we're doing to improve the test bench, Core 5 Verif test bench. I'm not going to go through the detailed features of that here. We can talk more in the BOF if you want to come and have a discussion about sort of best-in-class processor verification. I'm not sure that'll happen at this conference, but if it does, that's even better. But the point is, from the beginning of creating this ecosystem, understanding that you can, in fact, go in and throw your badge down and bet your job on that high-volume production SoC tape-out with something you downloaded off a public GitHub repo. Because we've got the quality built into the work. And when I say we, I'm talking about the member companies and the engineers that participate from those member companies in the ecosystem. Because all of our projects are collaborated on in the public domain by engineers from the member companies. That's the we I'm referring to. Okay, so that's good. We got a half-decent license approach that seems to be okay. The quality of what we've got from a verification standpoint seems to be okay. But what happens next? After I use this one core that I'm interested in, how do I continue on my roadmap of my product? Is there going to be another core that comes down the road for the next generation and variants and derivatives of these cores and so on? So what about the roadmap, and what about the broader ecosystem with operating system porting and tools and platforms and so on, just like you'd expect to see from a commercial IP developer? So we have a cores task group, like I said earlier, that actually curates the cores. That's chaired by some individuals from Silicon Labs and Thales. And these cores that we started with actually came out of ETH Zurich in Switzerland under Professor Luca Benini's leadership. And one is like a Cortex M4 class core, CVE4, so an embedded class, 4-stage deep microcontroller class core. And then the other is a CVA6 application class 6-stage core, capable of running SMP Linux in a multi-core cluster, available in both 32-bit and 64-bit. Originally developed as a 64-bit core, but with variants being released also as a 32-bit core. And as a result, there's 9 different cores on our roadmap. Those 2 cores were the seed cores, and we have variants of each of those that end up producing 9 different families of cores, if you will, or a family with 9 different cores in both. That's very yellow, isn't it? In both the embedded domain and in the application class domain. So difference being application class runs SMP or runs Linux and has a memory management capability, and embedded class runs an embedded RTOS or bare metal as an example. So beyond the cores task group, as I said earlier, there's software task group and a hardware task group. And the software task group does all of the software enablement around these cores, just like you'd expect to see in a within a commercial IP company that was licensing processor IP. And it's chaired by Jeremy Bennett from Embecosm and Yunhai Shang from Alibaba. And this task group has, in terms of the sheer number of projects, probably the most projects of any of our task groups, spread across a variety of different technology points. As I said earlier, ranging from the tool chain development to OS porting to simulators, so that you can be developing without a target and piece of target hardware. So all the green boxes are part of the software task group, and then it's not. Yeah, sort of blue. This blue configuration comes out of the hardware task group, which we'll talk about in a minute in terms of the actual targets that are being developed against. So not surprisingly, the IDE is an Eclipse IDE that we use for our Core 5 family of cores. And the team at Ashling has contributed an open source IDE that goes into that SDK environment that I just showed. And we're using that exclusively now to bring up the various cores that we have, even run the test benches, the test bench that I showed you earlier with GCC, and some folks are using LLVM from a compile time standpoint. So it's a nice, stable environment for those of you that are familiar with the Eclipse IDE. And there's a bunch of different folks that are looking at Thea to bring that capability here, as well as a broad range of new targets, new processor targets in support of the roadmap that I showed earlier. So then on the hardware side, chaired by Hugh Pollitt-Smith and Tim Sachs, respectively, this is the group that looks after the FPGA emulation platforms. So what that means, maybe I'll just show it on the next slide in terms of emulation versus reference kits or development kits. Emulation platform, everybody familiar with hardware emulation? What it means and why you do it? Okay. So we don't care about the frequency that the core synthesizes to, as long as it's logically correct. This is the RTL that is targeted at an ASIC implementation. So the ultimate destination for the RTL is an SoC. It's not a soft core for FPGA, although we do have some of those, and I'll talk about that. We use these FPGA platforms as an early bring-up environment for the software development teams to get started before we have real silicon. And as long as it's functionally correct, that's all we care about. Even though we'll talk about an SoC where the processor frequency target will be 300 to 400 megahertz for an MCU, a controller class device, and that synthesizes maybe down to 50 megahertz when we stick it into the emulation platform. But it is logically and functionally correct in terms of how it executes. So we use platforms from from Digilent, the Genesis 2 platform and Nexus A7 platform, and they're just different size FPGAs to accommodate different size designs. And we're excited that with Global Foundries, who is a member of the Open Hardware ecosystem, we're taping out our first SoC implementation of the first core that we froze, the embedded class 4-stage core. That's the guy that's in the middle there, 32 E40P. That means it's 32 bits wide and a 4-stage deep pipeline embedded class core. It's a very, very simple MCU with hardly anything on it other than generic peripherals. And that the point is, it's around showing the capability of the MCU and the fact that this is a production-worthy open source implementation built in a relevant deep submicron technology at 22 nanometer, at the 22 nanometer node with GF here in Dresden, Germany. So it's very cool. And that's the hardware emulation platform that Frederick and Davide demonstrated yesterday, and we can have that in the Birds of a Feather session later tonight if you want to see and come and play with that. But where that's ultimately going is on this dev kit, which you can express an interest in being able to get notified of when this thing is available for order. It's a Group Gets campaign. Group Gets is one of our members and partners. So you can literally just go to the OpenHW website and follow the links to get to the Core 5 dev kits, and you can just, you're not making a commitment, just it's an email notification. You get on a list. We announced this platform earlier in the summer, and we have over 300 names on the waiting list now for this kit. So I'm pretty anxious for when it comes out. So all that to say that we think we've kind of learned, some important lessons with these 3 points, and we didn't set out with all of these objectives when we started the organization at the very beginning. It kind of morphed into, this is clearly what the ecosystem needs in order to overcome some of those challenges that I mentioned earlier, like if we're back at 2001 compared to the open source software community, make it pragmatic and realistic that you can combine open source IP with commercial IP and use commercial tools to get to production in relevant deep submicron technology. And you can, in fact, walk into your boss's office and bet your badge on leveraging this in high volume production systems. And that is the end of my talk. So I'm happy to take questions. I think we've got a good 10 or 15 minutes anyway. And as I said at the outset, let's, if you don't have plans for this evening, come join us at 7 o'clock. I want to put that slide back up. Maybe I'll put that slide back up. That one. Where we'll be talking about these topics. So thanks for your time, and happy to take some questions.
This is a question about, I would like to get a little more involved with this. I am currently the product owner for Eclipse Theia within Ericsson. And, I've already installed Teros HDL in Theia. It's really cool. It's GPLv3. I would love to be able to have Theia as a platform where you can have your software and hardware co-designed and then debugged simultaneously. And we have all the tech there. We need the community.
That is wonderful. Membership is easy. I send you a membership agreement, you sign it, you send me a check, and then you're in. But where are you based?
I am personally based in Montreal.
Okay.
However,
Yeah.
it's open source.
Yeah. No, I was listening to the English and I'm going, wait a minute, I think you're north of the border with me. So I'm in Ottawa, right? So this is a Canadian nonprofit. And as you know, there's a pretty big Ericsson facility in Ottawa as well.
Absolutely, yes.
So the co-design and simultaneous debug would be very cool. So let's, we can chat after, and the Core 5 MCU is a small, simple design. Frederick's already played with it, and to be able to bring that closer into the Theia environment and bring up a design like that with free RTOS alongside, or Zephyr, or pick your embedded OS that you want to run along with it, or even bare metal, be awesome. That'd be very good. So I'm happy to chat with you after, Matthew. That'd be good. Any other thoughts, comments, criticisms? Is this a good idea, a bad idea? You want to hear me sing? No.
Yes.
No? Here we go. Oh, thanks, Frederick.
That's easy. Thanks. So I see a lot of hardware cores. But as I perceive it, one of the big challenges of the whole ecosystem is the software stack. So going from SystemVerilog, I see, all the way down to actual masks that get projected onto the chip. So how do Synopsys and Cadence and Siemens Mentor participate, or do they see this as a complete attack on their ecosystem? And how do you see building a parallel open source stack next to them?
So are you talking about open source EDA?
Yeah.
Yeah. So I'm Mr. Analogy. I love, so that we already did the bet your badge with the, and this is the part where I take it on the chin, right? Where the open source purists say exactly that. Wait a minute. The RTL is open source, but look at all these commercial tools and this commercial IP I have to use. I mean, that's not open, so none of it's open source. Unless everything's open source, then nothing's open source. It's kind of like the punch in the chin. And, just pragmatically, very practically speaking, we're not going to be able to boil the ocean with a single match, right? This is a multi-layer onion, as I said a few times, that we have to peel. So how do we, embrace some IP blocks? We'll take a Cortex-M4, and this is not a shot at all against ARM. We love ARM. They're a great company. We wouldn't have the technology capabilities without Intel and ARM right at the table. But if everyone has a Cortex-M4 in every MCU on the planet, what's the differentiation of that? Where's the value out of that? How do we extend that design with accelerators, some purpose-built hardware that is really fine-tuned to the data that you're trying to deal with, like an IoT edge sensor and the power envelope that you're trying to hit? So it's really, really targeted custom hardware. Well, let's share the functionality of what that Cortex-M4 is and make it easy for folks to attach their own custom hardware around it. And this ecosystem uses the tools that the adopters use. So as soon as NXP and Intel and Silicon Labs and the Silicon team at Amazon and Alibaba and so on say that, yeah, we can actually get to high volume production with a well-verified design in 22 nanometer and below, 7 nanometer designs using open source tools, that's the tools this community will use. They currently don't have that view. They use Synopsys, Cadence, and Mentor tools. Mentor is a member, Siemens is a member of the OpenHW Group. Both Cadence and Synopsys are partners, and they want for sure to know that our verification environment runs on their tools, that our RTL synthesizes into gates in the appropriate targeted libraries using their tools. Within the OpenHW community, our engineering staff, 2 of the guys are sitting at the back, we have access to all of those tools provided by those vendors. Now, there are certainly parts of those companies that have IP that have a conversation to, hey, wait a minute, what's this mean for my business? Commercial IP, open source IP. So it's not an exclusive or, it's an and, right? And practically speaking, you're not going to build a relevant deep submicron SoC with open source tool flow. And we're not trying to solve that problem.
Okay, well, that was mainly my question, whether that was also a part of your endeavor to try not only make the IP cores, but make the entire flow?
Not
or
today,
do you feel
anyway.
it like that's for another team, another...
That's another match.
Yeah.
Right? The ocean's big. We got one match, and it's burning down. Right? So we're working on the cores. There are so many challenges associated with just getting your head wrapped around all of the layers to create a truly open source hardware environment. Not just the processor IP, but all the other things that you talk about. Open source PDKs. So sure, there's some, like GF is open source, they're 180 nanometer PDK. 180 nanometer, I was still at school when that was relevant. And believe me, that's a long time ago. Right? So, I think there are good initiatives that are underway in the industry. That's not what we're focused on. We're focused on something that you could take this quarter or next quarter to production. And the idea is match the tool flow that those companies use today, not try to convince those companies to use a different tool flow. Any other questions, comments? Matthew, got another one?
Yes, I do.
Yeah, awesome.
Okay. I'm sorry, I'm rather sleep deprived. I don't remember exactly the name of the product, but I believe it's Eclipse DAV or DAV Eclipse, which is a hardware, it's RTL level and just a bit lower design level Eclipse plugin. It's a commercial one done by I believe a Romanian company, and I was wondering if there was any way to reach out to them, because since they're already doing hardware design within the Eclipse ecosystem.
I've never heard of them. I don't know them.
Remember their name?
Is that you guys?
No, you're the competitor.
Oh, really? Well, I would rather know the name of your product then.
Okay, so we're Sigasi, and we make a IDE based on Eclipse and also on VS Code.
Could you repeat it louder?
Sigasi, S-I-G-A-S-I. And don't ask me what the name comes from, nobody knows. And we make an IDE that both supports SystemVerilog and VHDL development.
Oh, wonderful. Let's play together also.
So clearly both of you should become members. We have an existing, well-verified piece of RTL that you could just drop right into your development environment. And that board that I talked about, we have 300 names waiting for. That's 302. Okay, did you already just go click and sign up? Well, what you guys really want is the FPGA hardware emulation environment, because then people that are making changes to the code and debugging. In fact, if you were successful, you'd encourage one of the project teams that's doing development work right now to use Thea and your tool environment as the development flow for a new project inside OpenHW Group. That would be ideal. Yeah, so it's interesting, right? I made the comment earlier, and we can keep talking until we get kicked out of here, I guess. But I made this slide. I made the comment earlier that we use industry standard languages and verification methodologies. SystemVerilog it's a great standard, except for the fact that it's not implemented the same way by the top 3 EDA vendors. Yeah. So one of the things that we just sort of fall into is because all of our design work is open source, so we have coding principles, we have a linter to check what we think needs to be supported properly in terms of SystemVerilog implementations for good design practice. And the EDA vendors are actually using our cores to validate whether or not their stuff works. So the compiler and the SystemVerilog simulator in Vivado, or the FPGA flow from Xilinx, we break that all the time. And so does everybody else probably. You need to take the mic. We get in trouble if we don't talk into the mic. And I'm not allowed to go past this line here. So. Yeah, it's better if he says it.
I like just to add one comment. It's not that we do not
Right up,
support.
right up.
It's not that we do not support or we don't care about open source ADA tools. Those are the standards that we use to validate the APs. But then there are several projects that are actually using Verilator, for example, that is compiling the cores we developed, and it's actually running. So it compiles with Verilator, but it's not our primary goal or target.
No, that's a very good point. And the other thing is you can't. So Verilator's useful, but you can't run this test bench on Verilator, right? There's no UVM support in Verilator. There's
not even timing.
Yeah, no, exactly. So it's a requirement that our cores compile in Verilator, because that's just another. It's almost like another linter, if you will. And because we have such a strong academic community, being able to at least bring up a design initially and run it in Verilator to know that you pass the smoke test kind of thing is a good thing.
Quick question. You can repeat it.
I'll repeat it. Okay.
Do you guys do anything with register mapping, IP exact? Did you brew something yourself?
Actually, there's a few companies that are doing register mapping and have register mapping tools that just go and inspect the RTL and bring out a register description. One of the companies, I can't remember their name.
I was more asking, as an open source group, it might be interesting to try to unify such efforts.
Yeah, because everybody does it differently. Yeah.
Their own thing, and equally crappy, I'd say.
And so, we'd be happy for folks to say, this is the scripting tool that we want to use to pull out all of the different register details in a human readable form and so on. And this is what the CSR map looks like, especially if we had those tools open source. So what a lot of the commercial folks that are doing this is they use our cores as basically living, breathing app notes, right, that are in the public domain. They don't have to get an NDA. They can share the results immediately, and they contribute the results back. And so we get to at least have, this is the map, it was generated by this tool, and then an end user can do what they want in terms of deciding on their own tools. So we'd welcome any, that's that pragmatic, hey, commercial and open source. We're not trying to tell anybody that they have to open source their tool. But if they want to, we're not going to stop them. Anything else? All right, thanks everyone.